The distance to the sun has actually very little to do with the seasons. Some people think that we're hot in the summer because we're closer to the sun, but that's actually not true at all. The distance to the sun changes a little bit, but not much during the year, and it actually changes in the opposite way that you'd expect. During the summer, we're actually a little bit farther away from the sun than during the wintertime, just by a little bit. We're actually closer to the sun during winter. Going around the sun is called a revolution. It is not a perfect circle, it's an ellipse, and it takes 1 year. Remember, that's 365 days to go through one full revolution, one full orbit. Draw the orbit of the Earth and label locations when the spring, summer, fall, and winter start. Okay, so you're not going to draw a perfect round circle. You're going to draw one that's a little bit stretched out, a little bit wider than it is tall. That's called an ellipse. And the sun is going to be off-center just a little bit, like that. So let's label this. Let's see here. We're going to call spring down here. The first day of spring is when the Earth is right there. The first day of summer is when it's over here. First day of fall, and the first day of winter. To me, we've been in winter for a long time. But, according to the astronomers, winter only started a few days ago. I think it was December 23rd, 22nd, I forget the exact date. But the distance from the Earth to the sun at the beginning of winter is 14.6 million kilometers. During the summertime, we're actually a little bit farther away from the sun, 15.2 million kilometers. So it's not the distance to the sun that changes the seasons. It's something else, and I hope that you saw that in our lab activity. It's the angle that the Earth makes to the sun. And please stop, gentlemen. Please stop, gentlemen. And that results in different numbers of hours when things are heating up in the day or cooling off at night. Now, just out of to tell you more about the Earth's orbit, 365 days is not exactly right. What's the exact number for a full revolution? Anybody know? 365.25. It's an extra quarter. So if we started off at this spot right here, and we were to wait 365 days, just 365, we'd come up a little bit short. And then the next year we go around 365, it'd be a little bit shorter. If we keep on going around just at 365, we end up with the start of summer being way over here. And so that's why we have leap years, where we add an extra day to the year every 4 years to give the Earth a little bit more time to get back to the starting spot. Okay, review today's purpose. I will learn why summer has more sunlight hours. Than during winter days, more sunlight hours than winter days. Think about how we were looking at the spinning of the Earth model in your activity and how that worked out. The Earth rotates or spins. The axis is the imaginary line that spins around the center. The axis is the line that goes from the North Pole to the South Pole. It spins once a day. One full rotation, one full spin each day. And this axis that it spins around is tilted at about 23 degrees. It's slowly changing over the centuries. Not much, though. This tilt is the same throughout the entire orbit or the entire year. The entire revolution. The entire orbit. It's not always pointing towards the sun. Let me grab one of these orbits or models again. So here, imagine that my head is the sun and the Earth is right now the axis tilted away from me. As the Earth goes around the sun, around my head, the axis is always pointing in that same direction towards the ceiling, like this. And then right now it's tilted towards the sun, towards my head, and as it continues to go around, it's still pointed in that direction towards the ceiling, and eventually it gets pointed away from the sun again. But the orbit, the tilt itself in space is the same orientation all the time, going around and around like this. It is wrong to think that it's going around like this. Okay? Make sure that you don't think that the tilt is changing, pointing that way, and now it's pointing in that way, and now it's that. No. It's always pointing in the same direction, going around like that. Number 10. When the northern hemisphere is tilted towards the sun, there are more hours of daylight than the nighttime hours. So there's more hours of heating up, getting warmer and warmer when you're in the sunshine, and then the nighttime you're cooling off, but there's not as many hours of cooling off. So therefore you have more hours of direct sunlight lead to warmer temps. Number 12. When the northern hemisphere is tilted away from the sun, there are less hours of sunlight each day than nighttime hours. Fewer hours of less direct sunlight lead to colder temps. You can think of it like putting a pot of water on the stove, and you're moving it on the stove and then onto the counter, onto the stove, onto the counter. Well, the longer you put it on the stove, the hotter the water is going to be. If you put the water on the stove for 3 minutes, then on the counter for 1 minute. Stove for 3 minutes, counter for 1 minute. You have more time heating on the stove, so you can get warmer water. If I do the reverse, if I only put it on the stove for 1 minute, and then the counter for 3, on the stove for 1 minute, on the counter for 3, now you have more time cooling off, and the water's going to get cooler. All right. Number 14, the seasons in the southern hemisphere are opposite hours because they are tilted in the opposite direction, being on the opposite side of the earth. So when we have warm summer, they have cold winter. For them, Christmas is a summertime holiday. And that's the end. And now you have homework on Schoology.